Alright, so this is a practice problem from chapter 3, number 2. This is a typical projectile problem. Okay, and so we're going to be looking at an arrow that is going to fly in a projectile motion just like this. And we know that it has an initial velocity of 25 meters per second at an angle of 30 degrees. Now, I know right off that when I'm working with two-dimensional problems like projectiles, that I'm going to need to break it up into x and y components. And so actually, before I do anything else, I'm going to go ahead and take that initial velocity, which is 25 meters per second, and I know that it's 30 degrees, and so let's take that and let's break it up into an x component and a y component. You guys should be familiar enough with SOHCAHTOA by now that shouldn't be any problem to find these. The adjacent side is the initial velocity in the x direction, so that would be the cosine of 30 is equal to the adjacent over the hypotenuse. And so we'll bring our calculator, and so we'll go 25 cosine of 30, and that gives us 21.65. So this one is 21.65 meters per second. And then if we do the same thing with this one, we'll find out that it's 12.5 meters per second. Okay, so I've broken that up into components, which will be important later on. Okay, so the first question asks, what is the maximum height reached by the arrow? Now I know that the maximum height is going to be right here when it hits the top point. Okay, so I'm going to go ahead and mark this in a different color. So I'm going up to the top point. I'm going to start here where it was launched. Okay, now I know the height is a vertical displacement, right? And so what I'm going to do is I'm going to go ahead and I'm going to list the information that I have in the vertical direction. Okay, I know that at the starting point here, the vertical velocity is 12.5. So the initial velocity in the vertical direction is 12.5 meters per second. Okay, I know that the final velocity in the y direction, since this is my final point, it's going up, it stops, and it comes back down, right? That's what we learned when we were doing projectile motion. We're ignoring the horizontal stuff right now, so it's just going to go up, stop, and come down. And so my final velocity at this point in time in the y direction will be 0 meters per second. And of course I know that my acceleration is due to gravity, negative 9.81 meters per second squared. So I'm trying to find the maximum height, which will be the displacement in the vertical direction. And so that's what I'll be looking for. I look at my equations over here, and it looks like the one that I want to use with the two velocities, the acceleration and y, would be this one right here. Okay, so that's the one that we'll go to. We'll say the final velocity squared is equal to the initial velocity squared, right, plus 2 times the acceleration times the displacement, which is going to be y in this case. Okay, so I'm going to go to my calculator. I'm going to square the 12.5. So 12.5 squared is equal to 156.25. So 0 equals 156.25 plus 2 times negative 9.81. That will give me negative 19.62 times y. So I'll subtract the 156 is equal to negative 19.62y. Then of course I'll divide both sides by negative 19.62. So I'll take that 156, so we'll go negative 156.25 divided by negative 19.62, and we get 7.96. So y is 7.96, right? Yeah, 7.96. So that is my, in meters of course, that is my maximum height. So now I'm going to go on to part B. How far does the arrow travel in the horizontal direction? And returning to the same level from which it was shot. So this time I'm looking at a different point in time. I'm going to start at the beginning, right? And then I'm going to go to where it returns to the same level. And so I'm looking at two different points here. Okay, now let me list the horizontal information because that's what I'm looking at this time. I know that my initial velocity in the x direction is 21.65 meters per second. Okay, I also know that there's nothing causing that velocity to change, right? The horizontal velocity is the same everywhere. And so I know that the final velocity in the x direction is also 21.65 meters per second. The acceleration, of course, is 0 because there's nothing causing the velocity to change. And so I'm looking for time. Now the problem is, since I am looking for time, if I use this equation right here, which is the one that would make the most sense with what I have, acceleration being 0 will multiply times the time and it'll go away. Okay? So I can't find time if I use the one for displacement here, which is actually what I'm looking for. How far does the arrow travel? Then I'm going to use this equation, but again I'm going to multiply 0 times x, which makes it go away. Okay? And so I can't find time or displacement using this. And so what I'm going to need to do is I'm going to need to start with the y information. Okay? And so now I need to look at the y information at this point in time. Okay? I know that the initial, of course, is 12.5 meters per second. I know that the acceleration is negative 9.81. That's in the y direction, of course, meters per second squared. And I know that the vertical displacement from here to where it's at the same level, that would be y, would be 0. Okay? So this information here is at a different point in time than this information. That's why some of the numbers are different. Okay? And so given this, I should be able to find the amount of time that it takes to go from here over there, because I'm going to find the amount of time it takes to go up and down, which would therefore be the same amount of time that it's traveling in this direction. Okay, so I've got v naught y, I've got acceleration in the y direction, I've got the horizontal, the vertical displacement, and I've got time. So that looks like it would need to be the top equation here, right? And so it's going to be 0 is equal to 12.5t plus 1/2 times negative 9.81 times t squared. Okay, so I'll go ahead and multiply those. So I'll have 0 equals 12.5t minus, and then half of that. So I'm going to go 9.81 divided by 2, which is 4.95 t squared. So I'm going to factor out a t. So that'll be 12.5 minus 4.905t, right? Because I took a t out of this one, which leaves me with 12.5. I took out a t out of this one, which will leave me with the same constant, but only a t. And so now since this times this is equal to 0, that means one of those two has to be equal to 0. So either t can be equal to 0, or it can be, if I solve this, subtract the 12.5 and divide by negative 4.905. So negative 12.5 divided by negative 4.905, that will give me 2.55. So 2.55 seconds. Now obviously I don't want this time right here. I want the time at the end, which is 2.55 seconds. And so now I know that my time equals 2.55 seconds. And so now I can find the horizontal displacement by using either of these equations here. I'm going to go ahead and use this one. It looks a little bit easier. So we'll say x is equal to 1/2 initial velocity, which is 21.65, plus the final velocity times the time, which is 2.55. So let's do it. So we've got 0.5, which is 1/2, times 21.65 plus 21.65 times 2.55. And we get 55.2. So x equals 55.2 meters. And that is the total distance, horizontal distance traveled from one level to the same level again. Okay? And that's all there is to that problem.